Here we discuss cycles, or feedback loops. So far in the causal graphs we have studied, no variable is a cause of itself. That is, there is no variable that has a directed path of any length back to itself. In some causal graphs, however, there are cycles, directed paths that start and end at the same variable. Here we show a graph that depicts a feedback cycle between performance and confidence. Intuitively, better performance increases reward, which increases confidence, which improves performance. Graphs with cycles are a bit more complicated in how they represent causal systems. We usually assume that causation takes time, and if so, then it is not obvious that the variable performance that begins a cycle is the same variable as the one after the time to complete the cycle has passed. So a different way to represent the feedback cycle from performance to reward to confidence back to reward is as so, where time is flowing down the screen. With time explicitly included like this, then no variable can have a path back to itself. Economists often model systems in this way and call them time series. Causal graphs are always directed graphs. Causal graphs in which there are no cycles are called directed acyclic graphs. Causal graphs in which there are cycles are called directed cyclic graphs, or cyclic causal graphs. In many domains, feedback is a central part of the system under study. In brain science, for example, we're quite confident that input coming in from the senses does not proceed directly to output at the muscles or glands, but rather involves lots of feedback between brain regions on the way. The graph here, for example, shows an overly simplistic representation of the axonal connectivity internal to the hippocampus. According to this causal graph, the subiculum causes activity in the entorhinal cortex, which feeds back to the subiculum directly, and feeds back to it indirectly through the dentate gyrus, through region CA3, through region CA1. In our simplified model of the hippocampus, we can observe two cycles, a cycle of length 2, including the subiculum and the entorhinal cortex, and a cycle of length 5, including all the variables in the graph. Notice that in a cycle, any variable we choose is going to have a directed path to itself.